indicating this is the direction in which the observer is going to look at the object. So this is the front view of the object. So you can just see that the front view appears somewhat to be a U-shaped letter with a thickness of 25, and this thickness will be equal to 15 and this distance. So now we'll see how to calculate this distance. This total length in the front view is 80 mm, and from here till here it is 50, and this is 65. So this will always be equal to 80 minus 65, which is equal to 15 mm. So this will be totally 30. So 50 plus 30 is 80 mm. So we'll be having a letter U shape as the front view, that is the left limb of the letter U will be having a thickness of 25 mm, and the right limb of the letter U will be having a thickness of 30 mm. And the total height of the left limb of the letter U will be equal to 75, and here it will be having a height of 50. But however, in between this two limbs, that is the left and the right limbs, there is a slant surface of size 20 cross 25. So this surface we are going to create, and also towards the right limb it is being cut with a rectangular cross section like this, which is having a dimension of 15 cross 50. So this is the dimension. So this will be equal to 20 because the total width of the component is equal to 60, and since this limb is equal to 20 and this is having a width of 20, so total dimension of this cutout will be equal to 60 minus the sum of these two, which is 40. So this will be equal to 20 cross 15. So this is how you can judge the dimensions of the unknown uh, regions which is not mentioned in the part. So this is how you can come to a conclusion like what is the height or the width or the length of the protrusions or the cutout which is not having a dimension mentioned. So now you can just see that this will be having a height of how much? 50 plus 25, because the total height of the component is 75. So we need to have this particular cutout or the uh, cutout of this particular profile from a distance of 25 mm from the top. So now we'll see how to create this 3D part model. So what I'll do first is, let me first draw a rectangle of the base that is having a dimension of 80 cross 20. So this distance was also 20. So let me draw a triangle of 80 cross 20, and then I'll be protruding this particular rectangle to a height of 75 mm, or I can just have it till the height of 20 mm and then first create this profile. So create this profile on the top view of this rectangle and then protrude this to a height of 75 minus 20, which is equal to 55, and then have this region marked on the top view of the rectangle, and then protrude that particular to a height part to a height of 50 minus 20, which is equal to 30. So now we'll see how to create this 3D part. So after the creation of this base rectangle of 80 cross 60 with a height of 20 mm, now I've taken the extreme left limb of the part. So this is again a rectangle of 25 cross. So this is again a rectangle of 25 cross 60. So now let me select this rectangle, extrude this to a height of 75 minus 20, which is equal to 55. Now let me select the right plane. Okay, and then try to draw the triangular part, correct? So for that, let me draw the square first. So here it is having a width of 20, and from here it is a right angle triangle. So let me complete this profile. So this I have to do the protrusion to a depth of 25. Now this profile is ready, correct? So now we will have to consider this part. So let me select the top view again, select the line option, and then first do a cutout of 20 in between. So what I'll do is I'll first draw a line of 20 mm and then a line of 15. The total width of the cutout is 20 again, 15, and this will be equal to 20. So complete this profile, select this profile, and then do the protrusion to a height of, the total height is 50. So what I can do is 50 minus 20, because earlier I've given a protrusion of 20 mm. So this is the right view, but however this is a through cutout. So what I can do is I'll select the line option again. From here I will complete this profile. So select the line option. From this it is a distance of 20, height of 15. Complete this square, select the square, and then in the extend type select finite, and then give a cutout to a depth of 15. So this is a through cut now. So you can just see that the part has been created. This is the isometric view. This is the front view. So we can just verify if the dimensions are correct. So it is having a total length of 80, a total height of 75. That is the left limb, and the right limb is having a total height of 50. And this is having a width of 25, 25, and again this is having a width of 30. So which is equal to 80 minus 50, correct? Fine. So let us check out the dimension of this rib also, which is equal to 15. So it is understood that this will be equal to 30, and this is having a height of 50, that is the right limb of the part. And then this is again a right angle triangle with a square of 20, correct? 20 and 50. So the dimensions are correct. So the part model is done. So now let us save this. And then we'll create the draft. So the draft sheet 1 sheet setup, modify the sheet to A4 and tick show background, click on save defaults, click OK, fit the sheet to the screen, and then in the home window click on view wizard and select the part that you have saved recently. Ensure the scale is 1:1, and this is the front view of the part. So the dotted line indicates the cut portion, and this is the top view. So you can just see that it is hollow here, and this is the corresponding side view of the part. So go to the sketching window, select the line option, change the thickness to 0.13, and then draw the XY line and the X1 Y1 line. So from the point of intersection, draw a line of minus 45 degrees. So now let us fix the side view. So for that, take the horizontal projectors from the top and then draw the vertical projectors. The extreme projectors I've taken first. I'll select the side view and then click on the move option. Ensure the copy is off. Select the bottom corner point, the left corner point of the part, and move it on the end point of this projector. So now the side view is adjusted accordingly. So now complete the views. So this is the front to side view projection. This completes the projection from the top to the side. This completes the projections. So go to the annotation, select the font style to Times New Roman, label the planes, that is X, Y, and this is X1, Y1. These are the reference planes, and label the views also. So this view that we get to see here is the front view. This is the top view. This is the left side view in the right profile plane. Select the leader, change the color to black and ensure it is a filled arrow. Indicate the directions for the projectors that we have drawn. Okay, so go for the angle between. Select this plane and this 45-degree line. Show the angle as 45 degrees. So go for the smart dimension. So in the side view, I'll be able to see the total height of the component and the total width of the component to the depth of the component, which is equal to 60 mm. And then here, the left and the right limb height has to be shown, so which is equal to 75 and 50 respectively. And here I'll have to see this as 25, 25. From this point to this point here, it is 15, correct? And this in this top view, let me show this as 20, 20. So since it is equal to 60 here, this is understood that it is equal to 20 again. From here till here, it is equal to 20. And then this dimension is already shown, which is equal to 20. And the depth of this is shown in the front view, which is equal to 15. So I guess we have completed with all the necessary dimensioning. So this completes the orthographic projection of the part. Thank you all for watching.